Hi guys, so welcome back to the um actually I'm happy to let you know that this is the episode 50 of Learning Kotlin Live. So today we're going to talk more about Coroutine, which we started to cover in 40 episode 46. And by the way, I was working after hour yesterday to deal with something that I cared a lot about, so I just totally forgot to um, come back home and go live. So sorry for letting you guys waiting yesterday, but it's April 1st, so maybe that's not that bad. Anyway, cancellation and timeout. So we have talked about a little bit. We have covered a bit, really a bit about coroutine. So now we know that coroutine are lightweight threads that can be started at different scopes, and also we know that what else do we know? Well, you can start a coroutine in inside a coroutine, and it would be kinda tree-like. And coroutine are lightweight, and so because um, we can create a lot of coroutines, and they will not explode like we would if we were using threads. And coroutine is like daemon, and I should correct myself. Global coroutines are like daemon, and they will not cause memory leaks. So that's all we have learned till now. So today I think we're going to talk about cancellation and timeouts. So yeah, it's also partly related to what we called um, what we just covered, the coroutine, global coroutine as daemon part. So let's look at this one. So last time we tried this. Let's see if we can get to the coroutine playground. It's actually Kotlin playground. Play Kotlin. And okay, maybe this is where we were last time. Perfect. So if we have a run blocking, let's see. Oh, actually no, this is not quite what I am expecting. Let's see what I have played. Nope. But anyway, let's try this. So if we have a main block, which probably run blocking, is that going to work? Does it have some like format? Oh yeah, it's working. So this is supposed to be repeated 1,000 times, but because this job is cancelled later here after 1.3 seconds, so it is cancelled. So after it is joined, these two, this block and the coroutine is joined, which kinda means wait for another one. So because it is joined, so it is now oh actually so it is joined, it is cancelled and joined. So wait, if we don't cancel, it is, if it is not joined, of course we can it can quit. But if we join without canceling, that would be problematic. we'll see a 10-second timeout here, because this Kotlin playground restricted everything to be terminated after 10 seconds. But anyway, let's see. How about repeat 5 for 5 seconds? So it is still going to end, but not after 5 seconds. So we're tired of waiting, but we didn't cancel, so it's still because we have joined it, so this coroutine started to block our main function. And if we cancel it at that moment, oh wait, my mouse is working weirdly. Okay, better. So because we have joined it, and because we have canceled it, so even when we have joined these coroutine and this main function, it is still the whole run block, the whole main block is still terminates in like 1.5 seconds at one point, after quite close to 1.3 seconds. So that's it. That's about how there's two ideas here. So if you join a job on your thread, you're going to wait for it to terminate. And also, well, you're going to get blocked here. And if you cancel it, it will be canceled. So any items that has joined it, if this job is joined and blocking one of those threads, it's going to be released and it can run, it can continue. That's the two ideas behind that. And cancellation is cooperative. What does this mean? Coroutine yeah, I'm still coughing, sorry. A coroutine code has to cooperate to be cancelable. All the suspending functions in coroutines are cancelable. They check for cancellation of coroutine and throw cancellation exception when cancelled. So by cooperative, it means that it will notify you by throwing an exception. However, if a coroutine is working in a computation that does not check for cancellation, then it cannot be cancelled, like the following example shows. Cancel and join. And because the cancellation is not checked in this block, so it would wait for all 5 loops to be done. Yeah, you're tired of waiting and you canceled and joined, but you have canceled it, but let's see what happens here. Oh, maybe here. Wow, it's still canceled and joined, but this is canceled and joined, but it is still waiting. Why? If you don't check for cancellation. Because this is some normal loop, but instead repeat is some normal loop as well, but delay is a suspend function. So if a coroutine is working in a computation and does not, by computation it means non-suspendable function. And if that non-suspendable block, which is this case, then it will not be cancelled. So here it's going to talk about how we make it cancelable. There is an is active. So let's see. Where does this active come from? Is active. It's probably from. Is active is an extension property. There you go. That is available inside the code of a coroutine via coroutine scope object. So yeah, this block is some computation code, and you need to check is active. And then you can cancel that computation. So remember, if you have some suspend function inside that computation code, it probably doesn't count as a computation code anymore with that coroutine. As you can see now, blah blah blah. Coroutine resource with finally. Oh, so. Oh, and if the cancellation exception ever get fired, you can handle it with that try catch. So, yep. That's the idea. So even if we cancel or cancel and join, the finally is always still run. So it's still safe. I'm running finally and now I can quit. So you need that join to get everything done actually. So how about this? And yeah, the finally still run because we never cancel. But without that join, I don't know. And here it is. Run non-cancelable block. Any attempt to use the suspending function in the finally block of the previous event cause cancellation exception. If you, yeah, that with context is a coroutine builder. Because the coroutine running this code is cancelled. Huh? Okay. Usually this is not a problem. So this directly gives you a cancellation exception. Yeah, no, I don't see it. I don't see one. Oh, because there's a delay. Delay itself is a suspend function. So again, let's read it again. Any attempt to use a suspending function in a finally. Yeah, it's using delay in a finally block of the previous example. Because the coroutine running this code is cancelled, usually this is not a problem since well-behaving closing operations, closing a file, cancelling a job are usually non-blocking and do not involve any suspending functions. However, if in a rare case when you need to suspend in a cancelled coroutine, you can wrap the corresponding code and with context. That's the reason why. Without that with context, non-cancelable, these items will be directly cancelled. And there will be an exception. No, why? I am expecting an exception in this delay. Probably because this whole code is wrapped in a coroutine, I guess. That's my guess. And yes, exactly. Yes, that's the... Yeah, it's in a run blocking. So, what if... Let's see. I don't get what's happening then. What is this, the purpose of this when with context? Oh yeah, yeah, it is. Um, a cancellation exception is fired because we don't see that this line anymore. 1, 2, 3, 4, 5, 6, and there is no because I'm cancelable. But with context, we'll probably see, and I've just delayed. Here it is. So yes, we need that with context, non-cancelable, and any finally block, even in some coroutine. Or maybe I should say it is important only because it is itself in a coroutine. We don't care about it if it's not in a coroutine, actually. Timeout. The most obvious reason to cancel coroutine execution in practice is because its execution time has exceeded some timeout. Yeah, that's timeout is something that is so cumbersome in Java as well. Well, you can manually track the reference to the corresponding job and launch a separate coroutine to cancel the track one after delay. There is a ready-to-use with timeout function. So with that with timeout function, if you wrap a coroutine with that with timeout, it's going to run after that time, and it triggers a timeout cancellation exception. So let's try catch it. What's the name of it? Timeout cancellation. EX. Here it is. Hello cancel. Hello cancel. Have type. Oh, okay. I'm writing the Java style again. And there it is. So, yep. It's timeout, and yeah, we can catch it if we try catch it if we want to. There it is. So the timeout cancellation exception that is run by with timeout is a subclass of cancellation exception. Also, itself is a cancellation exception as well. We have not seen its stack trace printed on a host console before. That is because inside a console coroutine to be normal reason for coroutine completion. In this example, we have used with timeout right inside of main function. Let's see the whole full code. It's directly inside a run blocking, and with timeout, wait. Inside a cancelled coroutine, cancellation is considered to be a normal reason for coroutine to inside a cancelled coroutine. Okay, because we cancel it a lot. Here and here and we're not canceling here, but we are not seeing the cancellation exception as well. So that probably makes sense. Oh, or did I? Oh yeah, there it is. And here is the cancellation exception. And it is, I think that means that it is handled by the default crash handler, or what's the name of that? Java crash handler. Yeah, exception handler. There are some global exception handlers in Java which help you print the stack traces, and it is also, let's see, global exception handler. There it is. Yeah, by some uncaught exception handler, blah 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 interface, and sorry. So yeah, my guess is Kotlin help you handle all those cancellation exception. Because, however, in this example, we have used with timeout, right, in time, blah blah. Because cancellation is just an exception, all the resources are closed in a usual way. That means you can still rely on the finally block. That's my that's my translation to what it just described. You can wrap the code with timeout and try catch block if you need to do some additional action specifically on any kind of timeout, or use with timeout or new functions. With timeout or no functions, that is similar to with time but returns no on timeout instead of throwing an exception. Aha. Oh, there's a result of that. Nice. So that's basically everything for today. I don't think we have time for channels, and I think channels is experimental as well. Probably we'll take a look at composing suspending functions next time. Then coroutine context and dispatchers. Yeah, these are definitely something I want to learn. So yep, I think even though it's still early today, I'm going to call it a day, because I don't think it's wise to talk about too many things in a time, especially when Coroutine is such a new idea to me. So I don't see anyone asking questions in live. Please remember to ask anything in live, or just make a comment on my videos, and I will try to get back to you as early as possible. So that's all for today. Nice. So see you guys next time at Learning Kotlin Live episode 51. Goodbye.